Time feels like the one thing in the universe you can always depend on. A second is a second. A minute is a minute. And an hour never changes. Or does it? What if I told you that time is not constant? That it bends, slows down, speeds up, and behaves differently depending on where you are in the universe?
Right now, as you are watching this video, time is literally flowing at a different rate for people above you, for satellites orbiting Earth, and even more dramatically, for objects near massive stars or black holes. Today, we're going to break down exactly why time moves slower in space, step by step, with simple explanations, real scientific experiments, and mind-bending consequences for humanity. This is not just physics. This is the true structure of reality.
For most of human history, we believed time was absolute. Ancient philosophers thought time was like a river flowing uniformly from the past into the future. Even Isaac Newton, one of the most influential scientists in history, believed time ticked the same rate everywhere.
Einstein shattered that idea. In the early 1900s, he proposed something radical. Time is not universal. Time is relative. Time depends on speed and gravity. This single insight changed modern physics forever. But what does it mean for time to be relative? How can something as fundamental as time bend or stretch? Einstein's greatest contribution wasn't just a theory, it was a new way of seeing the universe. He proposed that space and time are not separate things. They are woven together into a single four-dimensional fabric called space-time. To visualize this, imagine a huge sheet of stretchy rubber. Place a massive object, like a planet, on it, and the sheet bends downward. Smaller objects nearby roll toward it, not because something pulls them, but because the surface is curved. That is gravity. But here's the part most people don't realize. Time is part of that fabric. So when space curves, time curves too. This means time flows differently depending on the shape of space-time in your location. The deeper the curve, caused by mass or gravity, the slower time moves. This is the foundation of everything we're about to explore. High gravity equals deeper space-time curve equals slower time. Low gravity equals shallower curve equals faster time. You experience this effect every day without noticing it. In 1971, scientists flew 2 atomic clocks on airplanes around the world and then compared them with a clock on Earth. The clocks showed different times, confirming Einstein's prediction. Gravity alters the rate of time. Later, placing one atomic clock at the top of a mountain and another at sea level showed the same effect. The clock higher up, less gravity, ticked faster. Even tiny differences in height can change time. This means astronauts orbiting Earth experience time slightly differently than people on the ground. Gravity makes them age differently, though the effect is minuscule, measurable only with atomic precision. Gravity isn't the only factor. Speed also affects time. According to special relativity, the faster you move, the slower time passes for you relative to someone standing still. This is the basis of the famous twin paradox. One twin stays on Earth, while the other travels at high speed through space. When the traveler returns, they are younger than their earthbound sibling. This is time dilation in action. The faster you move, the slower your time flows. If you travel at 90% of the speed of light, 1 hour for you might be several hours on Earth. Imagine that when you move close to the speed of light, you're sliding through the universe's time differently than everyone else. That's the effect of speed, but there's something else that bends time even more dramatically: gravity. The closer you are to a massive object, the slower your time runs. GPS satellites orbit far above Earth, where gravity is weaker. Their clocks run faster than ours on the ground. Without correction, GPS would be off by kilometers every day. Time runs faster up high.
Time runs slower down low where gravity is stronger.
This means we constantly adjust the flow of time to make sure your Google Maps still guides you to the right place. At CERN, particles moving near the speed of light live longer than they normally should because time for them slows down. If you live on a high mountain, you age slightly faster, just a few nanoseconds per day, than someone living at sea level. The difference is tiny, but it's real. Time truly flows differently depending on where you are. Everything you've heard so far isn't theoretical. It's measured, tested, and used every day. Now for the most extreme example, what happens when you get close to a black hole? A black hole's gravity is so intense that even light cannot escape. Near it, time can slow down by thousands of times. To someone watching from a distance, you would appear to move slower and slower, eventually freezing at the edge of the black hole. But from your own perspective, time feels completely normal. And if you somehow escape, the outside universe may have aged hundreds of years while only hours passed for you. This means traveling into the future is possible by entering regions where time slows down. A spacecraft traveling close to the speed of light would allow astronauts to experience time far slower than people on Earth. And surprisingly, this already happens to astronauts on the ISS. They return to Earth technically younger, by a few milliseconds, than everyone else. In the future, we may even use time dilation to build supercomputers that run faster than anything we can imagine. By understanding time, we can plan interstellar journeys that last decades or even centuries. Astronauts may leave Earth and return to a world that has completely transformed. This forces us to ask a deeper question. What is time really? Is it just an illusion shaped by our brains? If time can change, what else about the universe is not what it seems? We're tiny observers trying to understand a colossal structure made of space and time. In the end, Einstein's message is simple. Nothing is absolute, not even time. Time can bend, stretch, slow down, or speed up. It isn't a fixed thing. It's a dimension woven together with space. And we're all moving through it, each at slightly different speeds. The beauty is that time is far more mysterious than we ever imagined. And by understanding it, humanity may unlock paths to the stars. But the real question is, how will we choose to use that power? Time isn't fixed. Time is alive, and our journey to understand it has only just begun. If you want to explore more mysteries of the universe with me, don't forget to like, subscribe, and comment. The cosmos still has endless secrets waiting for us.